Wingardium Leviosa. Wingardium Leviosa. Oh, hey, third graders. Just practicing my magic as I'm here at Hogwarts School of Witchcraft and Wizardry. And today, your lesson's going to be about the magic of adding and subtracting. Alright, so seriously, we are going to be working on adding and subtracting with regrouping. Alright, practicing our algorithm. I know it's a skill that you might think, I'm adding and subtracting, that's simple stuff. It may be, but it's the simple things that we need to become the strongest in order to help our minds continue to grow and learn and become better and better. So this is about practicing and strengthening our skills. Even if you feel like you're already strong, we can always become stronger. So we're going to be practicing doing the algorithm. I'm going to have the base 10 blocks on my screen. Now, I realize you probably don't have base 10 blocks at home, right? Because who has those at home? Not even I have those at home. However, I am going to share the app with you. It'll also be on the screen the same slide where you find your lesson. And so you can go back and forth to that app or practice with the app afterwards. Or maybe you just want to draw the tens, hundreds, and ones on the paper that you're working along with. Because it's still important that you work along with it. And it's probably easier to watch and work along on paper than it is go back and forth between the app. So, anywho, I just wanted to let you know that is available. Alright, third graders. So I am going to put on my invisibility cloak while you go do some adding and subtracting. Learn something and have fun. Okay, we're going to get back to the basics here, practicing our adding and subtracting on the algorithm. It's good to practice the basics because that's how we become strong, even in the little things. So we are going to start off by adding 165 plus 117. So I realize that you more than likely don't have base 10 blocks at home, but this is something that you can sketch and still work along with, and you for sure can do the algorithm part. So make sure you're at least following along with this part and sketching the hundreds, tens, and ones can also be helpful to your understanding. So since we're adding these two numbers, that means we're putting the two numbers together. So far as the base 10 blocks goes, we need to represent both numbers so we can represent putting them together. So, all right, so here we have 100, 6 tens, that's 60, and 5 ones, 65, and 100, 110, and 7 ones, which is 117. So adding the numbers, we got to put them together. We're going to start in the ones place. So in the ones place, I have 5 and 7. If I put those together, you should get 12 because we have 1, 2, 3, 4, 5 here. And then we keep counting 6, 7, 8, 9, 10, 11, 12. So that makes 12 in the ones place. So do we need to regroup and make a new 10? We are going to regroup here because each place will only hold 9. Once you reach 10, you must regroup. And we have actually passed 10. So see right here, I have 10 ones. So let's trade those in for a new 10. So we traded those 10 ones in for a new 10. I'm going to put this up at the top. So on our algorithm, we did 5 plus 7, but instead of putting 12 there, the 2, because that's what we have, only 2 ones left over, and we made a new 10, so I'm going to put a 1 new 10 over onto the tens place. So now, let's see how many 10s do we have. Well, 6 10s and 1 10 makes 7 10s, plus the brand new 10 that we just added in would make 8 10s. And then in the hundreds place, we have 200s, because 100 plus 100 makes 200. Therefore, 165 plus 117 equals 282.
Ants above ground plus 43 ants underground. 7 plus 3 equals 10. Each one of them is my special insect friend. 0 stays on the floor, the 10 heads next door. The sum is getting close, so I add once more. 1 plus 3 is 4 plus 4 is 8. My little brother thinks they would taste great. We mathematicians add with precision. And 15 hens are outside. To find out how many hens are in the coop, we gotta know how to add and regroup. 9 plus 5 equals 14. Write the 4, the 10 carries. 1 plus 2 is 3 plus 1 is 4. I wish the farmer was a herbivore. We mathematicians add with precision. It's inevitable, but check your work and it'll be indubitable. The best way to check your addition is by subtraction, the inverse operation. Take either addend and subtract from the sum. If you get the other addend, your work is done. When presented with a double-digit problem number, rockers always check after we solve them. We mathematicians add with precision.
Okay, now we're going to subtract 264 minus 189. To represent this, we only need to build 264. Okay, so we have 264 represented here, and we're going to take away from it 189, starting in the ones place. So in the ones place, I have 4 ones, and I need to take away 9 ones. Do we have enough to do that, or we need to regroup and borrow from the tens place? Well, 4 is not enough to take away 9, so we do need to regroup. So we are going to borrow 110. Hello, Mr. 10. And move it over to the ones place. So in our algorithm, we don't have 6 tens anymore because we moved 1 over to the ones place and make 10 more there, leaving us only with 5 tens in the tens place. So, but this new 10 that we moved to the ones place, it's in the ones place now, so we got to break it apart into ones. Okay, so we broke that 10 apart into 10 more ones. And now we have enough to take away 9. We have 14 ones minus 9 ones. So let's take away those 9 ones. Okay, so after we took away those 9 ones, that leaves us now with only 5 ones. All right, moving to the tens place. I have now only 5 tens left after I regrouped, and I need to take away 8 tens. Do I have enough to do that, or do I need to regroup and borrow from the hundreds place? Well, 5 is not enough to take away 8. So we do need to regroup. So we are going to go next door to the hundreds place this time. Hello, Mr. 100. And then move that hundreds place over to the tens place. So on our algorithm then, no longer have 200s because I moved 1 over to the tens place, making 10 more tens. So I need to break apart this 100 to make the 10 tens so I can see that I have 15 tens now. Okay, so after I did that, you can see now we have 15 tens, and we still need to take away 8 of those. So 1, 2, 3, 4, 5, 6, 7, 8. You are gone. So after we take away those 8 tens, how many tens do we have now? All right, so after we took away those 8 tens, that leaves us now with only 7 tens. All right, now in the hundreds place, I have 100, and I need to take away 100. So how much will that leave left? Well, it's real simple. 100, take away 100, leaves 0 hundreds. So we have nothing left in the hundreds place. I don't need to put a 0 there because there's nothing that comes after that. So that means 264 minus 189 equals 75. All right, guys, I feel like we just grew stronger with our addition and subtraction by building up those brain muscles. Good job.
30 hens were hanging in their chicken pen. 11 of them suddenly jumped over the fence. How many hens remain in the pen? To figure out the difference, we use subtraction. I say 0 minus 1 can't be done, cause the top number's smaller than the bottom one. So we regroup a 10 into 10 ones. When the top number's smaller in subtraction, I say 0 minus 1 can't be done, cause the top number's smaller than the bottom one. So we regroup a 10 into 10 ones. When the top number's smaller in subtraction.
19 heads remain in the pen.
There are 20 bumblebees flying around me. So I yell, shoot, and two decide to leave. Now how many bumblebees are chasing me? If we regroup, we can find the difference with ease. 0 minus 2. Here's what to do, cause the 0 is smaller than the 2. So we regroup a 10 into 10 ones. When the top number smaller in subtraction, I say 0 minus 2. Here's what to do, cause the 0 is smaller than the 2. So we regroup a 10 into 10 ones. When the top number smaller in subtraction, son.
18 bees are still chasing me.
That's all, folks.